Trigonometry exact values with Adam Maths Tutor. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. Trigonometry exact values are specific trigonometric ratios for key angles that students are expected to know without using a calculator. These angles are 0, 30, 45, 60 and 90 degrees. They are derived from geometric principles and are frequently tested in the GCSE Maths Paper 1 non-calculator. The exact values are not given to you in an exam and need to be remembered. Here's a table showing all of those that you need for your exam. There is a more simple diagram that can be memorized which will help you to find these exact values. And the diagram looks like this. So to find cos of 45, we'll need to look at the row that involves cos, which is this row here. And we'll need to look at the column that involves 45 degrees, which is this column. So cos of 45 will be equal to the square root of 2, using the correct row and column, divided by, or over 2, root 2 over 2. For the next question, we're writing down the exact value of sine 30, using my easier diagram to remember, and using the row that involves sine, along with the column that involves 30. Sine of 30 will be equal to the square root of 1 over 2. Some of these can be simplified further. The square root of 1 is 1, meaning that the sine of 30 is a half. For the third question, we're finding the exact value of tan 60. Notice the diagram does not involve a row for tan. To work out tan of 60, we'll actually use some A-level knowledge, where tan of theta is equal to sine theta over cos theta. So tan of 60 will be equal to sine of 60 over or divided by cos of 60. So we'll start by finding sine of 60, which is the square root of 3 over 2. Next, we'll find cos of 60, which will be the square root of 1 over 2, which simplifies to give me the same as sine 30, which was 1 over 2. And using the fact that sine 60 divided by cos 60 is equal to tan 60, I'll need to do root 3 over 2 divided by 1 over 2. And using keep, change, flip, root 3 over 2 multiplied by 2 over 1 gives me 2 root 3 over 2, which simplifies to give me root 3 over 1, which is the same as root 3. Lastly, I'm not asked to find an exact value, but I am asked to find a length from a right angle triangle, which I'll be able to do using trigonometry SOHCAHTOA. Start by labelling the lengths. Opposite the given angle, opposite the right angle, will be the hypotenuse, which means that this length next to the angle would be the adjacent. The question involves the hypotenuse and the opposite. This will involve using the sine ratio. Since I'm finding the opposite, I'll cover this bit up, and this tells me that I need to take sine of the angle, which is sine 30, and multiply this by the hypotenuse, which is labelled as 12. I already worked out above that sine 30 was equal to a half, but if I hadn't done this already, I would need to use my diagram or my exact values table to read off sine 30. Sine 30 is a half, and a half of 12 centimetres will give me 6 centimetres. On to the intermediate questions, with a slight increase in difficulty. These types of questions involving non-right angle triangles will involve the sine and cosine rule, and therefore will only appear on the higher tier papers. We need to find the length x, which is opposite a given angle, where the other two lengths are known, so the cosine rule can be used to help us with this. We'll use the version of the cosine rule where the length forms part of the subject. A squared equals b squared plus c squared minus 2bc cos of a, where a is the length to be found labelled x. B and c are the other two lengths labelled green. It doesn't matter which way round we label b and c as 5 or 8. And cos of uppercase A, where this is the angle opposite the length to be found, of 60 degrees. Obviously I don't have a calculator, so rather than using this to type it in and using cos 60, I'll need to use my knowledge of exact values to find out what cos 60 is. Cos of 60 is the square root of 1 over 2, which simplifies to give me a half. And I'll need to simplify the rest of this using written methods. 5 squared is 25, 8 squared is 64, and I'm taking away two lots of 5 multiplied by 8 is 40, multiplied by cos 60, which I've just used exact values to find a half. Simplifying further, 25 plus 64 is 89, and taking away two lots of 40, which is 80, multiplied by a half is 40. X squared is equal to 49. which means x is the square root of 49 and is 7 meters. For the next question, we need to find the area of the triangle, leaving our answer as an exact value. We have two lengths of the triangle with the angle formed between them. This means we'll be able to use the sine area rule, half AB sine C, to find the area of the triangle, where A and B are the lengths that form the angle. So a half multiplied by 5 multiplied by 8 multiplied by sine of C, where C is the angle formed between them of 60 degrees. Since I don't have a calculator and the question involves finding sine of 60, I'll be able to use my knowledge of exact values to help me. Sine of 60 will be the square root of 3 over 2. So simplifying this calculation, a half of 5 times 8, which is 40, multiplied by root 3 over 2. A half of 40 is 20, and multiplying this by root 3 over 2 will give me 20 root 3 over 2. The 20 over 2 numerical part will simplify, leaving me with my final answer of 10 root 3 meters squared. On to the advanced questions, some of the trickier questions that you're likely to find on this topic. We need to find the length of Z. Z is the length opposite a given angle, where the other two lengths are provided, meaning we can use the cosine rule to help us find one of the missing lengths or angles opposite each other. We'll want to use the version of the formula where the length forms part of the subject, a squared equals b squared plus c squared minus 2bc cos of a, where a is the unknown length to be found, so z squared is equal to b and c are the other two lengths provided in no particular order, 2 squared plus root 12 squared minus 2 lots of 2 times root 12 multiplied by cos of the opposite angle 30 degrees. We're tackling a non-calculator question where cos 30 is required. My knowledge of exact values will be helpful. Cos of 30 is equal to the square root of 1 over 2. Z squared is equal to 2 squared, which is 4, plus root 12 squared, which is 12, minus 2 lots of 2, root 12, 4 root 12, multiplied by cos of 30, which we have worked out to be root 3 over 2. Simplifying further, 4 plus 12 is 16, minus 4 root 12 root 3 over 2. Z squared is equal to 16. 4 divided by 2 will give me minus 2 root 12 root 3. Combining the surds, root 12 and root 3, 2 lots of root 36. Since I know that root 36 is 6, z squared will be equal to 16 minus 2 lots of 6. Z squared is 16 minus 12, which is 4, meaning that z is the square root of 4 and is 2 millimeters. For the last question, we need to show that the value of cos 30 multiplied by tan 60 plus sine 30 is an integer. I'll start by working out cos 30 using the row for cos and the column for 30, which is the square root of 3 over 2. Now I'll move on to look at tan 60, remembering that tan 60 is equal to sine 60 divided by cos 60, so I'll need to start by working out these two. Sine of 60 is equal to the square root of 3 over 2, and cos of 60 will be the square root of 1 over 2, which simplifies to 1 over 2. Therefore tan of 60 will be root 3 over 2 divided by 1 over 2, and using keep, change, flip, I'll end up with a final answer of tan 60 being equal to root 3. And lastly, I'll work out sine 30. Sine of 30 is equal to the square root of 1 over 2. So sine 30 is a half. Now I have my values for cos 30, tan of 60, and sine of 30. I can take my value for cos 30, which is root 3 over 2, and multiply this by root 3 before adding a half. Multiplying root 3 over 2 by root 3 will give me 3 over 2, and adding this to a half gives me 4 over 2, which will simplify to give me 2, which is an integer. Here's a question that I completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are and write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.